Hello, beautiful people, and welcome. In this video, we are talking about arithmetic series. Now, we're going to focus in this video on finite arithmetic series. Infinite will come in a different video. As always, disclaimer time, I am human. If I make a mistake, please let me know where the mistake occurs so that way I may learn from my mistakes, and then that way you can learn from my mistakes as well. All right, let's go ahead and jump in. A series is the sum of a sequence. So just in general, a series is a sum of a sequence. Since we are focusing on arithmetic series, it is the sum of an arithmetic sequence. So for example, let's say we have a sequence that is 2, 4, 6, 8, 10. And I'm going to put a dot at the end. Now, typically you may not see a dot at the end. What we're looking for is no 3 dots at the end. If you have 3 dots at the end, that means you have an infinite series. That means your sequence continues forever and ever and ever. Because we're focusing on finite, we're going to know what the last term is. We're going to know what the last position number is, and we're going to know what the last term is. So that's why I want to make sure that in my examples, I put a little dot at the end so you know that that is finite. All right, so now that we have our arithmetic sequence, what does it mean to be a series? What that means is I'm going to take all of my individual terms and I'm just going to add them up together. That's it. That's all series are. So I'm going to say 2 plus 4 plus 6 plus 8 plus 10. What does that equal? And that's going to be my arithmetic series. So for the sequence of 2, 4, 6, 8, 10, I'm actually going to use my calculator. So 2 plus 4 plus 6 plus 8 plus 10. I get a summation or the sum of 30. So a lot of the questions are going to be, what is the summation? What is the sum of the given arithmetic sequence? So make sure that if we're talking about series, so keyword, series, meaning add everything up together. Now, in the example that I just provided, you have 2, 4, 6, 8, 10. You have 5 terms. So 10 is in your 5th position, 2 is in your 1st position. So that's not too bad to add 5 numbers together using a calculator. That's literally what I did here. However, if you have more terms, like we're talking about 30 terms, it's going to take you a while to add things up. You can also make mistakes. You can just, forget to add a number with a lot of terms. So what we're going to do is we're going to introduce 2 formulas for you plus 1 sigma notation. You need to know all 3. What I recommend is for this unit, creating a cheat sheet off to the side so that way you have all of your explicit recursive formulas for your arithmetic sequences, as well as now these formulas for your arithmetic series. All right, so I'm going to actually highlight these in different colors, and I want to point something out. This sigma notation is this here. This is my sigma notation. Sigma is just the capital E looking thing. That is my sigma notation. This is the same thing, it just looks different, as this formula here, which is exactly the same as this formula here. So this is 3 separate formulas, 3 separate things that are equivalent, or they equal the same thing. All of them are summations. All of them are taking each term in the arithmetic sequence and adding them together. Now, obviously, they look different, so there's going to be perhaps different things to define, but I'm going to go ahead and try to do my best to make sure that I can show you the similarities as well as the differences. One thing I'm going to do first for our sigma notation is this here. I'm going to just rewrite this I as this I has disappeared. Okay, so how will this look like? I'm going to show you what the sigma notation represents. This right here, this sigma, this capital sigma, tells you to take the summation or take the sum of something, right? This upper number, doesn't matter what this number is, this is called your upper limit. This number right here, just the number, we don't care about the letter. This is your lower limit. I know mathematicians are not creative in their naming. One's on top, one's the bottom. Lower limit. This one right here, I'm going to see if I can switch colors so you can see it a little bit better. Let's see if this color show up. I don't know if this color will show up. This I is your index of summation. This is basically like your variable. Can you see that? Yeah, you can. And I'm going to write AKA index of summation. Don't let this variable trip you up. It just tells you that this is the variable that's going to be used inside of your formula. So if you see an X, there will be an X in your formula. If you see a Q, there will be a Q in your formula. If you see a W, there will be a W in your formula. Don't let that trip you up. All right, then this right here, this entire thing, see again if I can get a color, all of this in a box, this is going to be your formula. Now, it can be an explicit formula, it can be a recursive formula, it can be, most of the time it's going to be explicit. It can be explicit starting at 0 with the position number of 0. It can be explicit starting at whichever. So you're going to have a formula inside here. So how do you interpret that? What does that mean? So let's do an example. And let's say we have a summation of 2n plus 5 with the upper limit of 4 and the lower limit of 1. Notice that the n, notice that we had an n here. Now the n is on the bottom. It does not matter. N is just a variable. A variable represents an unknown something, right? An unknown number. So if this is n here, all that means is that you're going to have an n in your equation. That's it. That's all it means. Don't let it trip you up. Don't let the variables get confusing. Understand what each little part represents. So this represents your upper limit. This number represents your lower limit. So how do you read such a thing? Like this is weird looking, right? So what this all means is the sum from n equals 1 to n equals 4 of 2n plus 5. Now, I do want to point out something here in this thinking bubble, and I went ahead and I did it before I, did my notes. The number of terms is what the inside n represents. So this guy right here, this n, just like when we were doing the explicit rules for arithmetic sequences, this is your number of terms, not the lower limit. So this is not going in here. This is your number of terms. Okay, so let me point that in here. How do you find your number of terms? You take your upper limit minus your lower limit. Whatever number you get, you're going to add 1 to that, and that equals to your number of terms. Let me actually write that up. That's your number of terms. I don't think I made that any better, but that's your number of terms. So how do we deal with all of this? Let's talk about these two other examples. So this right here provides all the information you need to find the summation. Everything you need. In order to be able to calculate it, however, you do need a formula. And so these are the two formulas that you're going to provide, or I'm going to provide to you. They provided, mathematicians have figured out. I want to make sure that you see a little t here. So whenever you see a little t in there, that's going to be the number of terms. Now, typically you won't see the t unless I personally write it in there. Just understand that if you're doing it inside a formula, it does represent the number of terms. And you have to do this right here for the number of terms. So make sure that you know these two formulas. Now, we already know what a sub 1 is. A sub 1 is your term in the first position. This right here, the a sub n, that's going to be your term in the last position. And then this right here is going to be your number of terms. So how many total terms do you have? And I want to point out that this is exactly the same thing. So number of terms go here. First position. This right here is, again, your n, total number of terms. And then you have your common difference. It's easier, in my opinion, to work with this one here than with this. Notice this n minus 1 plus d plus 2a, that comes from your a sub n, okay? So it's basically we're reusing the sequence formula. Don't worry about it. We'll do some examples. All right, beautiful people, let's go ahead and start with example number 1. I will be completely honest with you guys. I am cutting and splicing these videos. I have recorded them multiple times. For some reason, each time it is being cut off mid-example, mid-sentence. So I'm going to try to put this one in. Hopefully, you'll be able to see all of it. For example number 1, we're going to find the sum of the given series. Now, this is for an arithmetic series that is finite. So we know the term, the last term that we're going to have. So what that means is I have a total n, right? N is always our position number. Then I know that this is my a sub 1, right? So a sub 1, 2, 3, etc. We don't know what the number is in the 10th position. Honestly, we don't really care. Do we care? Let's look at our formula and see if we care enough. So our formula, always have a formula sheet in front of you. I highly encourage you to have one page full of formulas per unit. Just keep adding it on. That way when you have a test or a quiz that you can use notes on, then you can just have all of that information in front of you. All right, so what that means is when we're trying to find the sum of the given series, is we're trying to take 1, 2, 3, 4, etc. This is our 10, so this is our a sub 1, a sub 2. We are adding all of these numbers together, and this is going to be our a sub 10. We know that we are stopping at the 10th term because they give us the n number or the position number. So our formula is a sub n is equal to n, and I'm going to do a subscript of t, which means our total number of terms, divided by 2 times a sub 1 plus a sub n. So apparently we do need to know what our last term is because we do need to know what a sub n is, a sub 10 in this case. So let's go ahead and do that here off to the side. We need to know what a sub 10 is. So we're using our original explicit rule. So a sub 10 is equal to a sub 1 plus d times n minus 1, or in this case n, right? So I'm just going to rewrite this real quick. A sub 1 we said was 2. Common difference, well, we need to find out what common difference is. What's the pattern? Each time I am adding, what am I adding by? 2, 4, 5, 6, 2. So I'm adding by 2, so my common difference is 2. My n value or my position number is 10, and I'm subtracting by 1 always. So let's find out what a sub 10 is. I have 2 plus 2 times 9. 2 times 9 is 18, so therefore a sub 10 is equal to 20. Now that we have our a sub 10 or our term in the 10th position, we're going to go back to our formula and start plugging numbers in. So the quantity of terms that we have, the n sub t, again, in the formulas in your book online, you won't find the subscript of t, I just want to make sure that you are aware that this is the total number of terms. So the total number of terms is how many actual digits you're adding. So this is 1, 2, 3, 4, 5. That changes if you're starting at like a sub 3. That changes if you're starting at a sub 0. Be careful. So in this case, we do have 10 terms. Our first term was 2. Our last term is 20. 10 divided by 2 is 5. 2 plus 20 is 22. And using my magical calculator, 5 times 22 is 110. You don't need any units here. These are just integers. We're just taking a bunch of numbers, adding them together, and we have our summation. So in this case here, notice that I still kept on my s sub n. That is technically incorrect because we do know how many digits we are adding. The summation of 10 digits is 110. All right, beautiful people, hopefully this does not get cut off. Fingers crossed. I love doing these, but if it's the same problem over and over and over, it gets a little tiresome. So thank you so much for watching, and I will see you in my next video. Bye.